Today we are going to solve some real life problems using the graphing skills that we developed in our last unit. What you see on the screen is the Navy Pier Ferris wheel. We are going to model the height of a rider as they travel around that Ferris wheel. The diameter is 140, the total height is 150, and the length of my ride is 7 minutes. And the question I'm going to investigate is how high the rider will be after 2.25 minutes. And you'll notice at the very beginning of the ride, the rider is not on the ground. They are actually 10 feet off the ground. The very first thing that I would like to do is graph this problem. And when our rider begins, he is at 10 feet. And I'm going to let my x-axis be t for time, and my y-axis is going to be the feet off the ground. And our ride is going to take a total of 7 minutes. So after 7 minutes, my rider is going to be back down at 10 feet. But halfway through the ride, at 3.5, my rider is going to reach the top of the Ferris wheel, and that's at 150 feet. And you can see that my curve is going to look something like that. Now, I like to divide my intervals up into 4 equal spots. So halfway between the 0 and the 3.5 is 1.75, and then halfway between the 3.5 and the 7 is 5.25. I'm also going to draw in my translated x-axis because my whole graph has shifted up. Now I can tell how high it's shifted because 80 is halfway between 10 and 150 feet. Now the next step is to write the equation of my curve. I'm going to do that on the next page, so I'm going to copy this over. I'm going to first write it as a sine graph. And I like to have the visual of my graph available as I do it. Now, to do this, I'm going to write some kind of function. A function of time is going to equal a times sine of b times x plus c plus d. And from our last unit, we know exactly what each of these parameters does. The very first thing that I did before when I tried to graph one of these equations is I found I was looking for the period. Well, in this case, we were given the period, and the formula that I used was that my period is equal to the original period of my graph, which for sine and cosine is 2 pi, over b. Well, I'm looking for b in this case, so I'm just going to substitute in that I know that my period is 7, and I'm going to solve for b. So now I know exactly what to put in for b into my equation. Now, the other parameters are actually easier to find than that. A is going to be the amplitude, and remember, A is this distance between your midline and your maximum value or your minimum value, and that difference here is 70. So now I know that A is equal to 70, and I already have B. I need to know C. Now, since I'm writing this equation as a sine curve, I want my function to actually begin there, and my sine curve has shifted to the right 1.75. So C is going to be a negative 1.75, and D is my shift of the graph, and my graph has shifted up 80. My translated x-axis is at 80. Now that I have each of these parameters, I'm able to write my function. F of t is equal to A, 70, sine of b, which was 2 pi over 7, times x plus c, which is minus 1.75, plus d, 80. So there is my very nice function, although it's a little bit on the crowded side, so I will try to move it over there just a bit. graph. Everything that I just wrote, I'm going to use exactly the same. I'm going to use the same A, the same D, the same B. The only thing that's different is the shift. And since I'm writing this as a cosine graph, I'm noticing that that is right where my cosine graph should start. It starts up an amplitude. So that is shifted to the right 3.5. So now my C is negative 3.5 rather than the negative 1.75. And all that's left is to write the equation f of t equals 70 times cosine of 2 pi over 7 x minus 3.5 plus my vertical shift, which was 80. So now I have two equations that will produce the very same curve. You really only need to write one, but I wanted to give you an idea how you might write, different ones. And also, you are able to write reflected sine curves and reflected cosine curves. But I think that I'll do one of these, and then I'll leave the cosine graph for you. So I'm going to paste this curve back on here again because I like to be able to see my graph. And again, everything's going to stay exactly the same. The only thing that's going to change is where I've shifted it. And since I am trying to write this as a reflected cosine curve, this is the value I'm going to pick. And unfortunately, my graph is off just a little bit here. That happens when you freehand things. This point actually happens at 5.25, right there. So my reflected sine curve is going to be f of t is equal to, now remember it's reflected, so I'm going to write a negative 70 sine of 2 pi over 7 times the quantity x minus 5.25, and I'm running out of room, so I'm going to make this a little bit smaller, plus my vertical shift, which was 80. And again, all three functions will give you the exact same values. I'm going to leave the reflected cosine graph for you to do tonight. And now, what I'd like to answer is how high that rider is going to be after 2.25 minutes. Well, all I have to do is plug the 2.25 in here. So I'm going to write my function f of t equals 70 times sine of 2 pi over 7, and I'm running out of room again, so I'm going to move this over, times 2.25 minus 1.75 plus 80. So we need some calculator skills to do this, and I'm going to move this up so that when I display my calculator, I am going to be able to see the equation. So it's right there. Now let's take a look at our calculators. The very first thing that you need to do is make sure that you are in radian mode. And you do that by pressing the mode button and going down to where it says radian. Make sure it's highlighted. Mine already is. I'm just going to press enter and then quit out of here. Now, when I find the rider, I am just going to enter in the equation. It's going to be 70 times sine of 2 pi over 7 times the quantity 2.25 minus 1.75. I'm going to have two parentheses there, plus 80. And my rider is 110.37 feet off the ground at 2.25 minutes. So I've essentially answered this question. Well, I have answered the question. 110.37 feet. So we were able to answer this. But now I want to ask a few more questions. I would like to know the next time the rider will be the same height as they were at 2.25 minutes if the rider kept going around on this Ferris wheel. In order to do this, I'm going to look again at my graph. And on my graph, the 2.25 is going to happen right in here somewhere. And they're 110 feet off the ground. You'll notice that my graph is symmetric over 3.5, or at least it should be if I drew it perfectly. And this is the next time they are going to be off at the same height off the ground, right over here. Because it's symmetric, these distances are going to be exactly the same. So the distance between 2.25 and 3.5 is 1.25, and it's going to be the same over here. So to find this value, I'm simply going to add 1.25 to 3.5, and that is going to give me, it's going to give me 4.75. That is the next point at which the rider will be 4.75 or 110.37 feet off the ground. Now that's if the rider stayed on. If they stayed on forever, which hopefully they won't, I would be able to find the times at which they were 110.37 feet off the ground by simply adding the period to each of these repeatedly. And the period again is 7. And I would be able to produce infinitely many times at which the rider is that far off the ground. The next thing that I would like to do is ask, at what times will the rider be 140 feet off the ground? Well, in order to do this, I am simply going to make f of t 140, and I am going to solve for t. And I'm going to solve this equation. I'm going to subtract 80 from both sides, and when I subtract 80 from both sides, I am going to get 60 equals 70 sine of 2 pi over 7 t minus 1.75. Now the next thing I'm going to do is I'm going to divide both sides by 70, and I will get 6 over 7 equals sine of 2 pi over 7 times t minus 1.75. Now, I need to solve for t, so I'm going to take the inverse sine of both sides. And now I'm going to multiply both sides by 7 over 2 pi. And now I will add 1.75 to both sides of my equation, and I have solved for t. Finally, I'm going to plug this into my calculator, and I am going to do this a little bit at a time. I'm going to work from the inside out. I'm going to take 6 and divide by 7. And now I'm going to take the inverse sine of that. I'm going to multiply it by 7. And I'm going to divide by 2 pi. And the parentheses are very important. And I'm going to add 1.75. And now I know that time is going to be 2.9 rounded. Now, at this point, I've forgotten what we're trying to find. 2.9 rounded. That's the time that they're going to be 140 feet off the ground. 2.9 minutes. And that is the end of my lesson.